All right, guys, very good evening to everyone. And we have to start our session. But before that, we'll have a very quick sound check, right? So let us check the sound. All right, guys, very good evening to everyone. All right, sound is coming fine. So we can start with today's session, right? So I'm going to share my screen and all right. So I have shared my screen and the topics that we have to cover today that I'm going to show you, people first of all, and then we will begin with our today's session, right? So this is basically what we are going to cover today, which is the dynamic sliding window, right? So I'm going to write the date here today. That is, we are starting this topic on 17/12/2025, right? So this is where we are beginning, and this is dynamic size sliding window, which we need to cover today. Right? Very simple topic and very interesting as well. So now, guys, what happens is that till yesterday, when we were looking at the sliding window examples, we were seeing that all of our window size were static in nature, which means that if this is our array, suppose, right? So if this is our array, and in this array, let's say that
Hello.
there are elements. Yes.
Yes, ma'am. Sorry, I was on a call.
What happened?
Like, if you, I mean, आप कुछ बोल रहे हो तो रिप्लाई नहीं किया होगा ना उसके लिए.
Acha. All right. So let's begin with this one, right? So today we are going to cover which topic? So it is dynamic size sliding window, right? So this is basically the topic that we are going to cover today, right? Dynamic size sliding window. Now what happens here is that till yesterday when we were looking at our sliding windows, so all the windows were static in nature. What it means is that suppose there are certain elements in the array. So this is our array and there are some elements in this array. So 12, 8, 9, 6, 5. So these are suppose our elements, right? Now till yesterday what was happening was that suppose if we have said that the size of window is 2, then it needs to be 2 throughout the question, right? So you cannot change the size. That's why that was a static window question. So you just have to scroll this window through your array, right? So one by one you were traversing your complete array, keeping the size of your window fixed, right? Whereas in dynamic size window, what happens is that you start with a single element inside your window, and then based on certain condition, the condition will be given in the question, right? So based on these conditions, whatever are given in the question, the size of your window can increase. Now, this size of your window can either increase or decrease as well. So how can that happen? So either you can say that let's increase the size of the right pointer. So there are two pointers that are required here to mention that what is the current length of the window, right? So there is going to be one left pointer, which is going to indicate that where is this window starting, right? And we need one more pointer, which is our right pointer, which is basically indicating that where is this window ending. So in dynamic size window, we need two pointers, right? One is left pointer, one is right pointer. And these pointer basically tells us that how big is this window, right? So if you want to increase your window size, you always have to increase it using this right pointer. So if suppose now I want that the size of my window should be 3, so I'm going to increase the right pointer, right? As soon as you will say that now right pointer is pointing to the third element, automatically the size of your window has increased. And if you want to decrease the size of this window, then that can be done using this left pointer. So as soon as you decrease the count of left or increase the count of left, your window size decreases. Right? In the similar way, if you want to again increase, then you can increment the right pointer. If you want to decrease the length of your window, then you can increment the left pointer. If you want to again do the same thing, then you can do the same thing. Or otherwise, if you again want to increment the left pointer, then there will be only one single element inside the window. So using your left and right pointers, you're basically in these questions, you're going to increase and decrease the size of your window. And you can see that while doing so, either you are having a lots of element inside your window, or you are having only a single element. So that's why, because your size of window is decreasing and increasing, that's why it is called as dynamic sized sliding window. So I think that the concept is pretty much clear why it is called as dynamic sized sliding window. This is very
Yes,
much clear to us, isn't it? Yes?
yes, ma'am. Yes, ma'am.
Yes. Right. So now, next thing is, let us understand this using a question, because using a question will better be able to understand it like more clearly, that what kind of questions can be asked here, right? So this is our first question. It is saying, so it is again a very simple question, but using this example, we are going to understand the concept very clearly. So the problem statement is that you're given an array of positive integers and a target sum. So let's first of all create these two. So it is saying that suppose you are having, so we're going to do it side by side today, because we want to understand like how to write the code as well, from the, from the approach that we are discussing. So we are going to open these both the panels side by side, and we're going to do all sort of coding today, like side by side. That's what we are going to do today, right? So let's say that this is our maximum length question. So we will try to understand the question. We'll try to build a logic as well. So this is our class max length. And now we are saying that, all right. So first thing comes first, which is, let's open it in the right hand side. Right. So this is our max length, and then this is our this is the place where we're going to draw some, arrays and everything. So it is saying that you need, basically you are having two right now two things as your input. The first one is an array of positive integers, and the second one is a target sum. So let's first of all draw it over here. So we are having one array, right? And it is containing all the positive numbers, by the way. So this is an array of positive numbers, and inside it we are going to mention these elements. So 2 is there, 3 is there, 8 is there, then 1 is there, then 7, then that's it, right? So these are the elements that are there in the array. And then we need one k value as well. So let's say that the value of k is right now. So k is basically the target, right? So k is not a window size here. So let's frame it as target only. So this is the another variable that we are having, which is target. So let's say that the target that we are expecting is suppose 9, right? Now, what is the question? We'll try to understand that as well. But before that, we are going to write the same two things inside our program as well. So these are two input things that are given. So we're going to write it over here. That first one is our array, in which we are having these elements 2, 3, then 8 is also there, then 1 is there, and then at the end we are also having this 7. And then this second variable is also there, which is target, and which is equals to 9. Now it is saying in the question that after having these two things, an array of positive integers and a target sum, you have to find the minimum length of contiguous subarray whose sum is greater than or equals to target. So it is saying that there is a possibility that there could be a lots of contiguous arrays, right? So contiguous array means that part of array means that it is talking about a subarray. Subarray means that the elements needs to be together. Right? So it is saying that you have to find out a number of elements such that the target sum or their sum is basically greater than 9. So you will say that the first window in which the sum is greater than 9 is 2, 3, 8. So it is basically greater than 9. So this is our first window which is giving us sum greater than 9. That we need to find out that particular subarray where sum will be greater than 9. Right? So this is one of the subarray. Then you will say that there is another subarray as well, which is 3, comma 8. So the sum of this particular subarray is also greater than 9. Right? Then you will say that there is another subarray as well, which is 3, 8, 1. Then there is one more subarray whose sum is greater than 9, which is 2, 3, 8, 1, 7. Right? And many more as well. But the point is that out of all the possible subarrays whose sum is greater than 9, you have to find out the length of that subarray which is minimum. Right? So you have to find out minimum subarray length. Right? So out of all the answers that are possible, you have to give the minimum length of that particular subarray, which is going to give you a sum which is greater than or equals to the target. So this is what this question is asking us. So we are like, okay, let's try to solve it. So how do we solve it? So first thing comes first, which is we'll try to. So I think that the problem statement is clear, right? That what this question is asking is very much clear to us. That find out the sum, minimum length of the contiguous subarray whose sum is greater than or equals to target. So this question is very much clear, isn't it?
यस मैम सॉर्ट
Right?
करके
No, we don't have to sort it because now we cannot sort it. The reason is that you have to find out contiguous subarray. It means
अच्छा
that you
हाँ
cannot, yes, you cannot take out the elements from anywhere, right? It has to be contiguous. So you cannot change the order of your array as well. All right. So we cannot change the order that we have understood. The second thing is if no such subarray exists, you have to return 0. All right. So now we will start with our sliding window concept. So we are initializing our window to be equals to 1. That is, now my window is going to contain only single element. So this is basically my window, and we are going to start finding out that particular subarray which is having sum greater than or equals to 9. So right now I am asking that what is the current sum of this window? So you will say that the current sum of this window is 2, right? And we have already defined this thing that we need two pointers. One is left pointer and one is right pointer, which will help us to give the size of this window. So we are saying that, okay, the current sum is equals to 2. So it is not greater than 9. All right. So the maximum length that we have got till this point, right? Because we have to find out the maximum length, right? So the maximum length that we have got till this point, whose sum is greater than or equals to 9 is 0. We have not found out any subarray whose sum is greater than or equals to 9. So if it is like less than 9, so we thought of it ki we have to increase the size of the right pointer, we have to increase the size of the window. So now what is the sum of this window? You people will say that the sum of the window, current sum of the window is basically 5, which is again not greater than or equals to 9. So this is also not a correct window. Then again, if this is not a correct window, then again we have to increment the right pointer. So we are saying that now we will again increase the size of this window, and now 8 is also coming inside the window. So as soon as this 8 will come inside, you will say that now the current sum is 5 plus 8. So all the elements that are coming, we are just adding them up, and now the answer is 13. So 13 is basically greater than the target, right? So as soon as we get this 13, we'll update our max length. We'll say that right now, the length that we are getting is right minus the right pointer minus left pointer plus 1, which is 3. You can see this as well, that there are 3 elements inside the window. So this is greater than the previous, this is smaller than the, all right. First thing is that maximum length you have to initialize with max value, because if you'll keep it as 0, then it will never be reinitialized. So here some maximum integer value was there, and now we are updating it to 3, right? But we want to find out a window whose length is minimized. So now we are going to decrement, or we are going to decrement the size of our window, because we need to find out the smallest possible window, right? So we are saying that, okay, let's do one thing. Let's decrease the left pointer. So that is, let's increase the count of the left pointer so that the size of window will decrease. Now the sum of these all elements inside the window has become whatever the previous sum was there, from that you have to subtract 2. So now the sum is 11. Now 11 is also greater than 9, right? So we are asking that, okay, what is the size of this window? So the size of window is 2. And what is the maximum? All right, so this is minimum length that we have to find out. So what is the minimum length that we have right now? It is 3. And is this new length smaller than 3? Obviously. So we'll say that, okay, update this length to 2, right? Now, because still the sum is basically greater than 9, so we are expecting that let's do one thing, let's decrease the size even further, because here we could have a 10 as well, right? So we are saying that let's decrease the size of this window and let's try to find out that if the size of this window will be only 1, then would it be able to give us a sum which is greater than or equals to 9? And the answer is no. Right now, the sum of the window is only 8. So now it is less than 9. So we have to again increase the count of our right pointer. And now the window is having a sum of 9 again. And now the count of your elements is 2. So the minimum length again is equals to 2. All right. Let's again go for like, increasing the window size. And again, it is greater than 9. So if it is greater than 9, then we have to count the size of window, which is 3. But some minimum length is already there with us. So we have to keep 2 intact. Then we'll decrease the size of this window. So we are saying that let's do one thing, that because right now the sum of this window is pretty much bigger than 9. So let's decrease the count. Now, after decreasing, the count has become 9, which is count has become 8, which is smaller than 9. So we can stop the process because right pointer we cannot increment. So that's why we are stopping the process altogether. So basically, what we have got from this algorithm is that there are two pointers which are moving simultaneously. One is our left pointer and one is our right pointer. So now the question is, when is this left pointer moving? So the left pointer moves when the sum of the window is greater than or equals to target, because we want to check that is there some smaller window available, because we have to always move the window in accordance with this rule. Whatever rule has been given, in accordance to that rule, we have to move the window. So we are saying that if sum, that is current sum of the window, is greater than or equals to target, then we have to move the left pointer. And when do we have to move the right pointer? So we are saying that whenever the sum is smaller than target, because right always increase when we want to increase the sum or increase the current count, right? So sum whenever is smaller than target, then we have to move the right pointer. So this is how basically these left pointers and right pointers, which are making up this window, are moving in order to find out the particular condition being fulfilled or not. In order to find this out, that's how these two pointers are moving. Does it make sense?
Yes, ma'am.
All right. So if it makes sense, then we are going to write the code, because the the most effective way to understand any algorithm is by writing the code altogether, right? So we're going to do that. Now we are going to go inside this implementation part, and we are going to see that how simple this is going to be for us. So we're going to
Ma'am,
do that.
problem number.
So right now it is not having any problem number. We are going to implement some simple problems first, which are direct implementations, right? And after some time, we'll do some lead code questions as well. So first of all, let's just strengthen our concept well, and then we'll go for some lead code problems as well. Right. So now what we're saying is that you people can try simultaneously side by side as well. Right. So now what our approach is telling us is that you need to have two pointers. One is left pointer and one is right pointer. So let's start with that. So this is our left pointer. And initially, if you remember, then we start with this particular window in which there is only one element. So it means left and right both were pointing to zeroth index only, right? So left pointer is also pointing to zeroth index, and right pointer is also pointing to 0th index only. So this is the first case. After this, we are saying that we also want to have one minimum length variable in which we are going to keep a maximum value, because we need to find out this minimum length, and initially we want to have some higher value here. So integer dot max value, this is our initial min length. After that, what else do we require? We'll see to it. If anything else is required, we'll write it down. Right. So these were the four things that we are having initially. Now we want to go for the implementation part. So we are saying that what is the current sum? So the current sum, you can simply say that whatever the ARR right, whatever this particular element is giving us, this is the sum that we are having right now. Because initially the window is having 2 as the sum, because right and left both are pointing to this 2 only. Does it make sense? Does it make sense that why the current sum is equals to ARR right?
यस मैम क्योंकि स्टार्ट हो रहा है ना.
Yes, because it is just starting, right? So, in fact, if you'll write ARR left, that is also making the same sense, right? Now, what happens is that we want to, like, now we want to either increment the right value, or otherwise will be decrement, or otherwise will be incrementing the left value. That is, we want to move this window. We want to increase and decrease the size of this window. So, how do we start with that? So, we are simply saying that suppose there is a for loop or a while loop, which is saying that this right should move until it is not reaching the last part of this array. That is, if suppose everywhere we'll get some 1, 1, 1, 1, 1, this kind of an array, then obviously right will only be moving, right? So that's why right can move until it is not reaching the last point. That is the maximum value right can go up to. So we are saying that while right is less than array dot length, till that time you have to move your right pointer. Right? And till what point this left can move? So left can also come up to this level only. That is, the maximum left can move is that it can reach the end of the array. Right? So, all right, these two things are clear. Afterwards, there were some rules written here that are if left
लेफ्ट लेफ्ट कहाँ तक पहुंच सकता है.
left can also come till this particular point. We'll discuss about left once more, but we are very much clear with the right pointer right now. So there are two conditions which are going to basically happen for left and right. That are if sum, the current sum. So we are going to write this code over here. That if sum is greater than or equals to target, then you have to move left, and this is the place where you are going to check that what is your current minimum length, right? And what is your current length. And if this length is a smaller than the min length, then you have to update this min length as well. So this is going to happen when this particular criteria is achieved. So let us do that thing as well. So we are saying that if the current sum is greater than or equals to the current target, whatever the target is, then we want to check that is this length, so the current length is equals to right minus left plus 1. So that this we can always calculate in no time, right? So we can easily calculate this. And after this calculation, we are going to say that, all right, now compare it with the minimum length that we are having right now. So if minimum length is greater than the current length, then we are going to update this min length. Then we are going to say that let us make this min length to be equal to the length, right? So this is how we are going to go for this particular case. And the second case is when sum is smaller than the target. So whenever the sum is less, all right, one more thing is there, which is you have to move the left pointer whenever sum is greater than or equals to target. So now we are saying left plus plus. And while you're moving your left pointer, you have to exclude your sum as well. So you're going to say that sum is equals to sum minus ARR left. So this is how you exclude that particular value. So whenever you are going to increment the left value, you have to subtract 2 from the current sum as well. So this is what we are doing in this if block. And what are we going to do in the else block? So as it is mentioned in the array itself, we are going to do a very simple thing, that is that first of all, because the sum is basically less than the target, so first of all, we are going to increment the value of right, and then while you are incrementing the value of right, whatever this new value has come out, that you have to add into your sum. So sum is equals to sum plus, and here you are going to write ARR, right? So whatever this new right value has come, that we have to include in the sum. And then again, the same thing will happen, that because right is smaller than array dot length, hence we are going to go again in the if, like the loop is going to work again, and we're going to again check if the sum is greater than or equals to target, or is it less than the target. Now, one case that can happen here is that while you are incrementing the right, it can happen that it will cross the the last index as well. So we are saying that if right is equals to array dot length, so this index is basically not available for us in the array. So at this particular moment we can break. Otherwise, we can keep on iterating, but as soon as right will become equal to the last the length of the array, we have to stop this complete algorithm right there. Right. So let's discuss this particular part now by dry running the code. So if suppose this is our array, let us see that how left is moving. That will also be clear to you people now. So suppose this is our array, and in this array we are going to have some elements as well. So let's take the same array which we have mentioned over here. So the array is this one, 2, 3, 8, 1 and 7. So this we have taken, right? So this is 2, then 3, then 8, then 1, and then 7. Now we need a window, and target element is equals to, so this is our second target, which is equals to 9. And we have to find out the smallest window that is possible for which the target is going to be greater than or equals to 9. Right. So now left and right are basically going to point the window size, right? So this is our left and this is our right. So basically there is only a single element in the window. This is our left and this is our right. Right. And then we are seeing that the minimum length right now is equals to the maximum value, some integer maximum value we have put here. And then current sum of the window right now we are saying is equals to ARR right, which is 2. So current sum is equals to 2. Now we are saying that you have to run this loop until right is smaller than ARR dot length. All right. So right is basically right now is smaller than ARR dot length. ARR dot length means that you're talking about index numbers 0, 1, 2, 3, 4, 5. So you are talking about fifth index, which we are not right now. We are not pointing to 5. So everything is fine. Now we're saying that if sum is greater than or equals to target, which is not the case. Right now, sum is basically smaller. So if it is smaller, then we are simply saying that if the sum is smaller, then you have to increment the count of your right, and whatever this new value has come, that you have to add into the sum. So let us do this thing. So we are saying that increment the value of your right. So now the right pointer is moving in the right direction, and this particular element is also included. So now the sum has become 2 plus 3, which is 5. Now again in the next iteration, so this else part is over. Then the next iteration, again we are checking that is this right is smaller than ARR dot length, and the answer is that yes, it is. So if it is, then we have to move this particular part, that is this sum is smaller than the target? Yes, it is smaller. If it is smaller, then obviously we have to run the else part, and in the else part we are saying that increment the count of your right pointer. So this right pointer we are incrementing. Now the right pointer is pointing to this index, right? So now the right pointer is over here, and then what we're going to do is that we're going to increment the count of our sum, and this will become 5 plus 8, which is 13. Now the sum is 13. So now we are again checking in the next iteration. That is this sum greater than 9? And this time, yes, it is greater than 9. If so, then it is saying that compute the length. So the length is right, which is 0, 1, 2. That is 2 minus left, which is 0, and plus 1. So that's how we are getting a length of 3. And then we are comparing it with the current minimum length that we are having. So obviously 3 is going to be smaller than this particular max. So we're going to update this to 3. And then what we're doing is we are saying that because this particular thing we have updated, so now we can move our left pointer. So now before moving the left pointer, we are saying that basically exclude this 2 from the sum. So excluding this 2 means that 13 minus 2, 11 is the current sum. And then it is saying left plus plus. So left plus plus means you are decrementing the size of your window. And now the left pointer has come to L plus plus means this particular place it has come to. Right. And then again the next iteration will follow, in which again it is checking that is this sum greater than or equals to target. And again the answer is that yes, the sum is greater than or equals to target. If so, then it is saying that compute the length, and this time the length will be right, which is 2, minus left, which is 1, plus 1, which is equals to 2. So this time the length is 2. And now we are checking that is this current minimum length is smaller than the previous minimum length? And the answer is yes. If so, then you have to update this with 2. So this is how we are updating the minimum length. And now again we are saying that, all right, because the current sum is 11, which is smaller than, which is greater than 9. So again we have to move the left pointer, because this was the case that whenever the sum will be greater than or equal to target, we always have to move our left pointer. So this time the sum is basically 8. So in the next iteration, when we'll again check that is this a correct case? So it is basically a correct case, and we are going to move in if or else. So this time the sum is basically greater than or equals to target is false. So we have to move to the else part. Right? In the else part, it is saying that you have to move your right pointer this time. The right pointer movement means that whatever this new value is coming, you have to include it inside this sum. So now the sum has become equal to 9 again. And again, you're going to check that what is this. In the next iteration, you're going to check that what is this length. So this length will come out to be 0, 1, 2, 3. That is 3 minus 2 plus 1, which is 2. And this 2 is already updated in the min length. So we are not going to do any kind of updation. In the next iteration, again, we are going to include one more element. Sorry, we are going to not include one more element. We are going to basically go for this one only, right? Because whenever the sum is greater than or equals to 9, we have to increment this left pointer. So this is how we are moving this left pointer. And then again, in the next iteration, you're going to include this 7. And in the next iteration, this will basically end. So this is how this whole working is happening for this algorithm. Does it make sense? Can you people write this code by yourself now?
Yes, ma'am.
Because our motive was, yes, so our motive was that we don't eventually, we just don't want to like understand the algorithm. We actually want to know that how to write a code as well. Because sometimes what happens is that we understand that how a particular algorithm is working and all of it's working and everything we understand, but as soon as we go for the coding portion, we basically are not that much comfortable. So that's why we have to become a little more comfortable as well. So you people also try to write this code. I'm giving you people 5 minutes, and then we'll go for the next question. And then you people have to tell me that how this left and right pointer are going to move in this question, right? So first of all, you people try this particular question, and then we are going to move to the next question. Try this one, guys. So this question is statement I'm going to give you. It was that suppose you are having an array of positive integers and any target sum is given to you, and what you have to do is you have to find the minimum length of the contiguous subarray whose sum is greater than or equals to the target. So this I'm going to give you, and you people have to try this one. I'm going to put your code also right in front of you, but you have to try first of all, without looking at the code, you have to try your question. After some time, if you are still won't be ready for it, then you can see to the solution, right? So try this one, guys. Do your hands-on exercise also side by side. Otherwise, it'll take a lot of time. So try this one, and then we'll go for the next question.
Okay.
This is not lead code question like this. I'm first of all, I'm just trying to build the concept, so that's why I'm giving you direct questions. But these kind of questions you'll find out in lead code as well. We'll discuss them afterwards. Don't worry. Good evening, guys. You people are late, huh? Your class starts at 8. Be on time. Whenever you're sitting in the class, you always have to have your laptops with you because this class is not at all something which you can just, look at your screens and you can understand. This is all about trying your concepts side by side. So always sit with your laptops open. Keep on doing practice while you are in the class. Otherwise, this will not make much sense. Like, try this question first. Is it done?
1 minute.
1 minute. I will show you the code, but you people always have to try to implement the codes by yourself. If you people will say, I'll give it to you people on GitHub also, but always try to implement the codes yourself.
मैम ग्राफ्स वगैरह का दे देना, या अभी तो नहीं.
All right. There is a single case which we have to handle, right? I'm going to tell you about that case as well. First of all, you people try this one and tell me once you people are done with it. Now, see, guys. Now, what happens is that when you're looking at this code, there is one case which we have not handled till this point, right? Let us try to understand that case as well. So, suppose this is our array, right? Let's take an example of some array, and let us say that there is this case in which initially all the elements in the array are 1, comma 1, comma 1, comma 1, comma 1. And then at the end, we are having this 9, right? And now you people know that the target that was given to us was 9, right? And we have to find out the window which is having minimum length. So obviously the answer should be 1 because this particular window will serve the answer, right? But this particular question is not helping, this particular algorithm is not helping us with this case right now. So how do we change this? We want to know. But before that, let us just dry run this particular case. Let us see it diagrammatically what is happening. So this is our current window. Initially, we are having this particular window. Then we will say that, okay, this current sum is basically smaller than 9. So increment the right pointer because this was the case that whenever the sum is smaller than 9, you have to move the right pointer. That is, you have to increment the size of your window. Then again, what will happen that the sum is smaller than 9 to increment the right pointer, that is increase the size of window. All right. Then again, it will increase the size of window because again the sum is smaller than 9. Then again, it will increment the size of your right pointer to increase the size of window. Right. And now at this particular point, when this window is this big, what will happen? That the final answer will come out to be 1 plus 1 plus 1 plus 1 plus 9. That is something greater than 9 only. And the size of window will be 5. Right. So you will update this 5, which is you will say that the length of your window is basically 5, right? But now what happens is that it says in the next iteration, it is going to say that because right is right now pointing to 0, 1, 2, 3, 4. So it is pointing to 4, right? But it is saying that we can use this while loop only until right is smaller than array dot length. So it is still smaller than array dot length. So it will say that, okay, use it, right? So it is going to use it, and then it is going to, because the sum is basically greater than and equals to target, so it is going to decrement the count here, right? Now what happens is that suppose here we are having this 9, and let's say, so this example will not suit our need, but still, so this is going to work very fine with the algorithm. So it is going to decrement the count each time, and once it will reach this particular place where the size of your window will become 9, it will say that, okay, update the window size, and this window will be, after changing its length again and again, 4, 3, 2, and at the end it will become 1, and this is the place where we are going to stop. But what will happen is that it will again say that do left plus plus, and the reason is that your right now the pointer, that is right pointer, is pointing to the last point, but the sum of this particular window is still 9. So it will say that left plus plus should happen, and this window will become a negative window, that is left will become greater than right. So this is the place where we have to stop. So we are going to say that do this thing, that is this particular if loop should work only until, so you have to do this whole thing only until, and left should also be less than array dot length. So you have to put this extra condition over here, that this should not happen, that your left pointer should not cross your right pointer. So that's why we are writing this particular case. Is it clear? And in fact, you can write this complete code. Yeah, it is working fine otherwise. So this particular concept you have to keep in mind, that you always have to check that this left should not cross your right pointer. Right now, if we'll run this example, that is, if we will take this example 11119, so the answer of the window should come out to be 1, 1, 1, 1, 9. So the answer of your minimum length of the window should come out to be 1. Okay,
मैम अंदर ही
we have not printed the length. All right, let's print it. So system.out.println, and what is the minimum length? Let us see.
हम ऊपर एक ऐसा केस नहीं लगा सकते जिसमें कि अगर एरे के अंदर ही वो टारगेट का एलिमेंट हो तो डायरेक्टली 1 रिटर्न कर दो।
Still, right now also your algorithm is working for n times, then also it is going to work for n time. So you're going to increase the time complexity if you're going to check it in some other format, right? So basically, you don't want an extra pass or something, right?
टाइम कॉम्प्लेक्सिटी में अंतर नहीं हुआ ना लेकिन
It is not necessary na, that you're going to get some value which is, so he's asking that if some value which is 9, that is equals to the target, if some sort of value we'll find, then we'll stop it right there, and we'll say that basically this value is greater than or equal to 11. So that's why the size of window will be 1, because it's smaller than 1. There's nothing smaller than 1. So here we can stop. So that is absolutely correct, but that is what our window is also checking. So the same thing our window is also checking, na, with the help of sum. So why to handle it with a extra case? We don't need
मैम
an
ये
extra case.
एंड वाला केस से बचने के लिए मैं सोच रहा था।
You can try this, but I don't think that you will like, this is a small case, you can use it, right?
ओके
But it is completely up to you. If you want to use some other kind of a strategy, completely up to you. So it is just about moving your window. How you want to move this window, that is completely up to you. Right. So let's go to the next question. Now the next question is, so it is problem statement 2. This time this statement is saying that suppose you're given a string S and an integer K, right? Yes, the time complexity will stay the same. And so that's why We are not using an extra case to match that. But otherwise, you people should try all the strategies that you're having in mind, because that's how you learn. So I will recommend that whatever strategies you people are having, try it once, right? Because these are simple problems as well. So let us see this question. So it is saying that this is our problem statement number 2. It is saying that you're given with a string s and an integer k, right? So I'll just zoom it a little bit. A string s is there and an integer k is there. You have to find the minimum length substring, right? So you have to find out the smallest substring that contains at least k characters, right? It means that you have to, or at least k occurrences of a condition. All right, that is basically a different thing. So you can start from here only, and we'll restructure our statement here. So we'll say that this is a problem statement in which they're asking us that suppose we have some string s. So let's see one string s. Let's say S, D, N, A, B, C, S, D, D. So something like this. This string is there. And then they're saying that suppose K is equals to 3. So K equals to 3 means that suppose you have to find minimum length string in which, so just try to understand the question, right? So you have to find a minimum length of a string which can give us three, say suppose three distinct characters can come. So they can be repeated n number of times, but there needs to be three distinct characters. So you would say that the smallest string that is possible is of length 3, right? Why? Because SD and it is basically containing all distinct characters. And here the value of k was 3, which means that you have to find out the smallest substring which will give you 3 distinct characters. Now let us change this question, this string. So now suppose the string is this one. And now we have to find the length of the minimum string in which 3 distinct characters will come. So we'll start again from the single window. We'll say that, let's say this is our first window. And I'm going to ask you that, are there 3 distinct characters in this particular window? And you will say that no, there's only a single distinct character. So all right. So it simply means that if the number of distinct characters in the substring are less than k, then we have to move the right pointer, because you have to increase the size of your window. And whenever you are having distinct characters equal to or greater than k, then you have to move your left pointer, because this time you can decrease the size of your window. So this question is basically absolutely based on the previous one. So we are starting from the very first place where the size of window is only 1. And now we are asking that, are there 3 distinct characters in the window? And the answer is that no, there is only one single character which is distinct. All right. So when there are less than 3 characters distinct, at that moment, we have to increase the size of our window. It means we have to move the right pointer. So now again, we are checking that, okay, how many distinct characters are there? And again, there is only one distinct character. But we need to find out a substring in which 3 distinct characters would be there. So the answer is again that this is also not a possibility. All right, let's move ahead. So this time AAB. So we are having 2 distinct characters. One is this equal to or greater than 3? Because we need 3 distinct characters. So again, your answer would be no. So again, we have to increment the right pointer. Now again, we're asking the same question, that how many distinct characters are there? And this time, you will say that yes, we have found out 3 distinct characters. So what is the length of this particular window at this moment? So you will say that right now, the length is 4. But we have to find out that particular substring where the length will be minimum. So again, what we're going to do is that, because this time we have reached this particular, this condition, so we have to decrement the size of the window, because maybe some answer can come. So as soon as you will decrement the size of your window, that is, you're increasing the count of your left counter, then you're going to get this ABC. So again, all 3 distinct characters are there, but this time the length is smaller than 4. So we are going to update this length, and this is our minimum length as well, because as soon as you will reach this place, that is k is equals to length. So smaller than this, there is nothing possible. So you can stop it right here. But say suppose that here instead of C, you could have got one A as well. So if you will decrease the size of your window at this point, you will find out that okay, right now it is not possible for us. So say suppose you are here and this is A. So two distinct characters are there only. So you will again increment the count, and this time the window will become equal to 5. And you will say that, okay, so there are three characters possible, but the maximum size right now we are reaching is 5. So you will decrement the left hand, there is the size of your window. Again, the distinct characters are still 3, but this time your size of window has decreased a little bit. Right? Again, you will decrement the window because still the condition was met. So again, you're going to get 3 distinct characters, and this time also your size of window is smaller than the previous size, which is 3 this time. And as soon as you reach this k, you can stop, or otherwise the second criteria is you will reach the end of the window. Okay, so that is also the case where you have to stop, that we have seen in the previous example. And one of the cases in which you can stop intermediate condition is that when your size of minimum length will become equal to k. So at this point also you can stop your computation right there. So this is how we're basically going to do this part. Is it clear?
Yes, ma'am.
Everybody? Ketan, is it clear? Now the point is that how do we find out that how many distinct characters are we having in the window? So for that, you people can use a hash map simple. In the hash map, you can simply keep the count of your variables. That like A is there and how many times it has appeared. So key value pairs you can generate. If suppose your hash map is containing 3 entries, it means that the value of number of distinct characters is equals to the count of your entries in the hash map. So something like that you can do, right? So you people can start trying this out, and later on I'll also help you. But first of all, you people think of the problems that you're having, because I want to discuss the problems that you're facing right now, and then we'll go for the implementation part as well. First of all, you people try. Try this one. You're having 5 minutes, and later on we'll discuss that how hash map can be used for it. You can try any of the approaches that you're having in mind. So there is no single approach to solve a question, right? You people can always try your own approaches as well. So whenever you have a random approach and you think that this can also work, just try that out, because that is the best way to learn. Left less than equals to right will also work, but you have to still put some extra conditions, because you always have to check that your index should not basically go out of range. So just keep a track of your edge cases as well. Shall I discuss, or you people want some time?
मैम डिस्कस कर दो.
Discuss? All right. So those who are like thinking that they can do it, they can start doing it, right? And for other people, we're going to basically go for the discussion of this question. So first thing that was given in the question was that you will be given with a string and a value k, right? So we're going to write that out here. So this is maximum, this is minimum length, right? Minimum length is string with some constant values. है ना? So this is, say, suppose this is our Java file, and then we're going to say that this is our main function. And within the main function, because the first thing is that you need to have one string. So string s is equals to a, b, c, and a, b, 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 then c, c, and at the end we'll have a b, a, right? So now we are saying that this is our string, and the value of k is, say, suppose it is 3. That is, we need to find out 3 distinct characters in this string. All right. So this is our string, which is A, B, 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 then C, then C, then B, and then A. So this is our string S, and the value of K is 3. That is, you have to find out 3 distinct characters in the string. So this is basically when your substring will become uh, basically I would say that it will become valid substring. So a valid substring would be when it will contain 3 distinct characters, that is k distinct characters, right? And as soon as it becomes valid, then you have to find out that what is the minimum length for this valid substring, because there could be a lot of valid substrings. But out of these many valid substrings, what is the minimum length of the valid substring? Because this substring is also valid, right? Because it is also containing 3 distinct characters. Then this substring is also valid, B, 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 C, C, B, A. So this is also valid, right? But the length of this substring is more than this first substring. So we have to find out a substring which will have minimum length, right? And is valid as well. So CBA, this is going to be our answer because it is containing the least amount of, because the length of this particular substring is least. So that's why this is a valid answer for us, right? So this is our question, and now we want to go for the solution. So we're going to start our left and right pointer again from 0. That is, left is equals to 0 and right is also equals to 0. That is, our window is currently holding only one element. So this is our window as of now, right? Now we want to make a hash map as well, because hash map is basically a data structure in which you can keep key value pairs, right? So we are saying that, okay, let's make this hash map as well. So this is our hash map. And inside this hash map, we are saying that the key is going to be a character and the value is going to be the frequency of that character. So it is an integer kind of value. All right, is equals to new hash map. Right. So this is how we have created a hash map. So this is our hash map as of now. Hash map is a data structure in which you can hold key value pairs, right? So initially this first element has come, that is A. So we are saying that, okay, let's create an entry for it. So whatever goes into a hash map is called as an entry. It is an entry object that goes inside this hash map. So inside this entry, you have two things. So first one is that what is the type of your key? So it is a character type value. So it means that we are going to keep a character over here in the key segment. And the value is basically what is the frequency right now of this particular character in the window. So there is only one A in the window. And now we are asking that is this window containing K number of constant letters? And you're going to say that no, it is not. So it is not a valid string. So this is how we are thinking of it, right? So initially the window is containing only A. So let us write the code over here. So we are saying that till what point do we have to search all of these things? So till the time right is less than s dot length. The same case, right? that till the time right pointer is less than s dot length, till that point you have to keep on checking, right? Now, what do we have to check? So we have to check that if the number of entries, now think about it, that if suppose A has come for 4 times, right, and B has come for 6 times, and Z has come for 3 times, but still the number of entries are going to be 3. So number of entries here depict that how many constant, so how many letters are there in the substring, right? Is it a valid substring or not? So how do we find it out that even if there are 4 A's and 3 Z's and 6 B's, but still it is a valid string? How do we know that? Because there are three different letters inside the hash map. So this is how we try to find out that how many distinct entries are there. So we are checking that case only. We are saying that if this hash map, right, this hash map right now is not containing 3 distinct characters. Right now it is having only one, which is A. So I'm going to write it over here. So there is only one A. So A comma 1. So 1 is its frequency. And now in the if case, we're going to write that if this map dot size, so map has this function size which gives you the size of map. If this map dot size is greater than or equals to k, right, or if it is equals to k, then you're going to simply say that this is a valid string, valid substring. So let us get the count of this substring, which is again right minus left plus 1. So this is how you get the length of this substring. And then you're going to update your minimum length as of now, whatever the minimum length is there. So minimum is right now integer dot maximum value, right? Integer dot maximum value is current minimum. So obviously it is more than the whatever length is going to come out. So we are going to update it only if this length is smaller than the minimum value right now, then we are going to update this minimum. So minimum is equals to length. And whenever this case will fit in, right? So right now this if case is not working. Right now this else case is working. That is map dot size is not greater than or equals to k. It is a smaller than k. So if it is a smaller than k, then we are saying then do this thing, right plus plus. And whenever you do this particular thing, that is right plus plus, then whatever this new variable is there. So suppose B is coming, right? So either there are two cases possible. So the first case is that this is a new variable, right? This is a new character. So if map does not contain this new element which is coming, so if map dot contains key, so which key are we talking about? So s dot char at right, right? So at this right place, whatever at this right location, this right is basically an index. So if it is equals to false, false means that this map is not containing this B, this second character. If this is the case, if the map is not having this character, then you have to put it there. So map dot put. So this is how you put an entry inside a map, right? So map dot put. So what is this character? The character is the same character, that is s dot char at this index, right? This right index. So you have to put this character and with the frequency value of 1. Right? So you're saying that this particular character is not there, so we have to put this into the map. But there could be another case as well, which is basically that this value could be there in the map already. That is, if this map contains this key already, then what do we have to do? So first of all, you have to get the frequency of this value out. So in current frequency, so what is the current frequency? Right, current frequency is equals to map dot get. Get function basically says that you give me the key, I'll give you the value. So we are saying that okay, we are talking about this particular character, right? Get the value for this character. So it will get some frequency. So it can be 1, 2, 3, 4, whatever it is. So it will get it out, and then we are going to say that okay, now let us put this again. That is, let us put this character again, but this time with what value? So with the value plus 1. So whatever current frequency we have got, we have to add this 1 into it. So this is how we are basically processing it. Right? So I think that this makes sense that how right is being evaluated. Right? And you can start your right from -1 in this case, and the reason is pretty simple, that we want to process everything inside the while loop only. So that first window will also be evaluated inside this particular place. Right. Now, the second case is what will happen if we want to exclude something from the map. That is, we want to remove something, which is when you want to move your left pointer. So at this particular place, what will happen is that when you want to move your left pointer, let us see this case over here. So right now the right has been moved. That is, first thing is that initially we are checking that, okay, what is our hash map's current status? Is it containing B or not? So the answer is that no, it is not containing B. So it is saying that if it is not containing B, then put this B inside the hash map with a frequency count of 1. So if you are putting your value for the very first time, so you always have to put 1 inside. But the next time, because right now the character count is not equals to k, so again you're going to increment the right pointer. So this time when you increment the right pointer, it is going to say that, oh, this B is already there. So it is saying that if this B is already there, then get its current frequency out, which is 1. And then in the next line, put this B again into the map, but with +1. So this is how we are putting this B again into the map with 2 as the frequency. And now if you will ask the map that how many different values it is having, different characters it is having, so the answer is 2. So it is still not matching this particular K, right? Then we'll keep on doing this, right? So again, you're going to increment the count of your particular window, and this will become B will come again. So this count will become 3. Then again, you will increment your right pointer. And this time when this C will come, right? So when this C will come, because this is coming for the like next time when the C will come, so it is going to put this C in the map. And now when we are going to check this, that what is the size of this map, right? So here we are going to check that, okay, what is the size of this map? And the answer is going to come as that, yes, this time it is equals to K. So now if it is equals to K, so it is your task to go, again, you have to check the length. So length you have checked by doing this, using this formula, that is right minus left plus 1, whatever the length has come out, that you have to update in the minimum if it is smaller than the previous one. And then the next thing is you have to basically increment the count of your left pointer. Right? So you are going to go for this particular case. You have to exclude this A from this map. So while excluding it, you have to check for two cases, that if the current character that you want to remove. So first of all, let us think about this, that what is this left character right now? So left character is equals to this s dot char at left, right? So this is how we are going to get this left character, and then we want to check it inside the map. So if map dot, so map is definitely going to have this character because it has processed it already. But we want to check that what is the count of this A, right? So if map dot uh, get this left character, right? So it is going to get this left character count, and if it is equals to 1, if the count of this character is equals to 1, then we have to remove this element from the map. So map dot remove this left CH. The remove function will basically do what is that it will remove this A from the map. But say suppose this second case could also have happened, that is A comma 2. Something like this can also happen. So in this case, you cannot remove this A. You have to just decrement the count of this A. So for that, we are going to write a one else case as well, which is saying otherwise you have to put, so first of all, get the previous value, previous count. So int previous count is equals to map dot get, and whatever this current left character is there, left character you have to put, but with whatever previous count was there, you have to subtract a 1 from it. So this is how you're going to do it when the current count is not equals to 1, right? So this is how we are going to go for it. And other than that, what is left? Let's think of it. So other than this, I think that everything is, we have handled everything else. Yes, one more thing that is left plus plus. So after that, you have to uh, basically move your pointer as well. So left plus plus. That's it. And at the end, you're going to have your minimum length out, system.out.println, and let us check that what is the minimum length. That is our min value. So one case we have not yet handled is, we will handle it afterwards, but first of all, let us check for it. So let's run it. So it is saying that out of range it is going. Let's move. Yes, so we have to put this condition as well, which is that if while moving your right pointer, when you have moved your right pointer, you have to check for this condition always. That is, if right is equals to s dot length, then you have to break, right? So you have to always keep in mind that you have to handle this case always. So final answer is coming out to be 3. But if suppose you are not having this a at the end, now we want to check that what is the minimum length. Let us see. It is saying 5 in this particular case. So this is how basically these all things are happening. Now your task is that you have to see to the code first of all, and first of all just see to the code. Then we'll discuss it further. So I will first of all paste this code onto your whiteboard, so that you people can have a very good look of it, and then we'll discuss about all of your doubts. I hope that it makes sense. Is it like a little bit clear? Are these classes making sense?
Yeah,
Yeah, everybody on YouTube as well.
YouTube वाले रिप्लाई कैसे करेंगे?
Chat box. ये बच्चा बोल रहा है कि YouTube वाले रिप्लाई कैसे करेंगे? और ये बच्चा डेटा स्ट्रक्चर्स पढ़ रहा है. चलो बच्चों फटाफट इसे देखो, and then we're going to go further and we're going to try the next algorithm. But before that, just make it very much clear. There are certain functions like map.put, map.get. You have to basically learn them, and in some of the upcoming classes, I'll just make your collection framework very much clear. Right? So don't worry about it. But till that time, just you have to learn these few, like you have to remember the names of these functions. Like map.get means it gets you the value of that particular key, right? Remove means that it basically removes the element, and contains key gives you a true or false value based on that is this map containing this particular character or not, right? So just look at the code, and if there is any doubt, first of all ask that, then we'll go to the next question. All right, guys, is it done? All right, so there is some discussion going on. All right, so even if the time complexity is 2 into n, it is still smaller than n square, right? So even if you'll consider that, all right, left and right, both pointers are going and 2 into n is the time complexity, still n square is pretty much way bigger than that, right? So that's why we don't want to go for brute force approach, right? So brute force approach says that you can use two loops, right? Two nested loops, and you can uh, uh, basically have a left pointer and a right pointer, and you can change the values and you can try all the cases that are possible, right? So, but we don't want to go for it uh, because of the reason that you people understand. That is, you will be basically having these pointers set, and afterwards, the time complexity will even increase because you're going to have one hash map and you're going to see to it that are there k distinct characters. So for that also, you're going to move this. Like one more loop is required. So that's why we don't want to go for it, right? It is very much computationally, it is very much heavier process. So this is way lighter, isn't it? Does it make sense? All right. Okay. So guys, I think that this is clear, right? That how we have approached this question. Now, I want you people to try some of the questions as your homework, right? So these are going to be simple question, and then tomorrow we will do some lead code questions as well. So I just want you people to try these 3, 4, 5, and 6 questions. So they are very much similar to what we have discussed till this point. So you people can take a screenshot of it, right? It will not take much time for you people. And then tomorrow we are going to do some lead code questions based on this topic, right? So I think that the topic is pretty much clear. Is it? Yes? And what about Ketan and the other student
Yes,
and
ma'am.
Ashutosh? Yes, right? So we are going to try the food questions tomorrow, but before that, I just want you people to try these 3, 4, 5, and 6. These questions. You can take a screenshot of it or something. All right. So this is it for today. And if you people have any doubt, you can ask. Otherwise, we'll wind up the session for today.
Good night,
Is
ma'am.
everything is clear? All right. Good night, bachcho. Bye bye. Take care.
Take care.